Hello again, math students. Today we are starting our chapter on solving systems of equations. You did a little bit of this last year, so hopefully this will look familiar. But the two vocabulary terms that I need you to know, first of all, it's called a system of linear equations. System just means that there's more than one. For us, we're only going to be worried about two for right now. And linear equations, those are lines. So we're going to have two lines. And we're going to try to find the solution. So that's the next one, solution of a system of linear equations. That's the ordered pair that's the solution for each of those equations. When we talk about solutions of equations, every single point on a line is a solution for that equation. If I have two lines, if they share a point, it's the point where they cross, that's going to be the solution. So when we are graphing today, and that's what this method is going to be, when we are graphing these systems of equations, we're looking for the point where the two lines cross. So when we graph both of these equations on the same coordinate plane, on the same graph, we're going to look for the point of intersection. That's step 2. When we find that point, it does say to estimate the point. We should be able to tell what it is. We're going to give you problems today that you'll be able to tell exactly where that point of intersection is. But I'll show you how you can also check that solution to make sure that it really does work for both equations. So in these three problems, I'm giving you an ordered pair, and I want to know if it's a solution to the system. That just means it has to work for both equations. If it only works for one equation, it's a solution for that equation, but it's not a solution for the system. It has to work in both. So remember, in every ordered pair, we have an x and then we have a y. So I'm going to substitute the x and the y into these equations. So this one would really just be 3 plus 1. Oh yeah, that does equal 4. And when I substitute here, 2 times 3, that's really 6 minus 1. Oh, that's not equal to that. So if I'm asking, is this a solution? Nope, it's not a solution. Now, please do not say that there's no solution. This is just asking if this one point is a solution. There may be a solution for this. There is a possibility of getting no solution, and we'll talk about that in a minute, but this problem isn't asking, is there any solution at all? It's just saying, is this a solution? So for the second problem, I have an x and I have a y. So I would have 1 minus 3 when I substitute. Oh yeah, that is equal to negative 2. It works in the first equation. 2 times 1 is going to be 2. 2 plus 3, oh yeah, that is equal to 5. So this is, yes, it is a solution. And for number 3, when I substitute this in, this is an x again, and this is the y. Be careful because these now look like slope-intercept form. So the y is first, so I would have 0 here. The x was 2. Oh yeah, 0 does equal 2 minus 2. And when I put it into the second equation, 0 here, negative 3 times 2 would be negative 6. Negative 6 plus 6, that is 0. So yes, that is also a solution. In these three problems, I have the lines already graphed for you. So, and I'm telling you they're graphed correctly. I'm not even asking you to check the graphs. For instance, here we could say, oh, if I wanted the second equation to be in slope-intercept form, I could subtract x and subtract x, and I would have that y equals negative. I'll put a 1 there. So that's going to be this line right here. Okay. But again, that's not what I'm asking on this one. I don't need you to do the graphing because the graphing is done. What I want you to do is use these graphs to solve the system, to find the solution. And then we also want to check the solution and make sure that it works in both equations. If it truly is graphed correctly, the point that we find, then it should definitely work. So the point of intersection is where the two lines cross. This ordered pair is at 2, negative 2. When it says to check the solution, that just means substitute in. So 3 times 2, That's going to be 6 minus 2 times a negative 2. So that's going to be, let me write that underneath, I guess. 6 minus a negative 4, which is 10. Good. And for the second equation, 2 plus negative 2, yep, that is 0. So that is the solution, and it works in both equations. For the other problems, we're going to find those ordered pairs, but I do want to mention one time that when we graph systems of equations, it would be possible for two lines to not cross. So if they were parallel, for instance, then they would never cross. That's when we would get a no solution kind of a situation. These are not parallel lines. They are going to cross. There will be a solution. So for number 8, this is -1, -3 is this ordered pair. So doing that substitution, the x is -1, subtracting 2 times a -3, that's going to be -1 plus 6, and -1 plus 6 is 5. When I substitute into the second equation, 2 times a -1, that's going to be a -2, plus a -3. -2 plus -3, yep, that's -5. In the last problem here, this ordered pair is at 4, 2. So doing my substitution, this would be 4 plus, now instead of showing that substitution, this is what I would do in my head. If the y is 2, instead of writing 2 times 2 for this right here, I would just say, oh, 2 times 2, that's 4. Yep, 4 plus 4 is 8, got it. In the second equation, 3 times 4 for this part, instead of writing 3 times 4, I would just go to 12. And then 2 times 2 is going to be 4. 12 minus 4, yes, that is 8. So that's how we would check those solutions after we find them from the graph. Now here is really what your work is going to look like today. The worksheet that you're going to have is going to be graph the 2 lines, find where they cross. That's our solution. Remember, these are in slope-intercept form, so y equals mx plus b. In my first equation, I could even get a 1 right there. So y equals -1x plus 3. That means we're starting at 3. My slope is -1 over 1, so down 1 over 1. Okay. This is why we reviewed graphing lines. For the second equation, it starts at +5. And my slope is 1, or 1 over 1, but it's going positive this time, so up 1 over 1. So there's my line. The point of intersection, the point where they cross, is right here. That ordered pair is at -1, 4. That's my solution. Remember, ordered pairs need to have parentheses. For number 11, I'm starting at +2. And the 1/2 slope means I'm going to go up 1 and over 2. Or down 1 and left 2. But it's got to look like it's going uphill. So there's my first line. Second line starts at +4, and it's got a -1/2 slope, so downhill, down 1 and over 2. And you guys have probably heard this from me a whole bunch of times. When I'm graphing lines, especially on the smartboard, I want to get as many points as I can just to make sure that my line is as accurate as possible. On paper, with a straight edge, it's not as difficult for you. This ordered pair for the solution is at 2, 3. And for number 12, I do need to show some work to get the y by itself. In that first equation, that's where there's really more work to do, I guess. Let's get rid of the 3x. So I would have -2y equals -3x plus 6, and then divide, divide, divide. So my equation is y equals -3 over -2 is going to be +3 over 2x, and then 6 divided by -2 is -3. So we're starting at -3, and my slope is 3 over 2. So up 1, 2, 3 over 2. and I don't have room to go down 3/2. Then, once I get that line graphed, sure that some people are looking at that second equation and worrying a little bit because it doesn't have an x. Remember, if it doesn't have an x, it's not going to cross the x-axis. It's going to be horizontal. So the y-intercept is -3, which is right here, and the slope is 0. If I wanted to write it in slope-intercept form, it would look like this. Y equals 0x, that's why the x went away, -3, which means it's a horizontal line right here. That point of intersection is at 0, -3. So again, today, what you're looking for your practice problems is graphing the two lines, see where they cross. The only lines that wouldn't cross would be lines that are exactly parallel. If you get lines that look like they're going to cross off the graph somewhere, that means you did something wrong. We made sure that those lines would cross on the graph. So this is the worksheet. I've mentioned this in class, but I'm going to say this to everybody. Please do the practice problems. Just watching me do this is not good enough to get it into your brain. You need to actually practice those, graph the lines, see where they cross, the answer keys in Schoology, and then when you're done with those practice problems, go ahead and take the formative. Let me know if you need any help.